in 4.2, we're introducing piecewise functions. So our objective by the end of today, we need to be able to graph and write piecewise functions. So we're going to start with evaluating functions, which is something we've seen before. So evaluating a function, f of x at equals x squared plus 5. This is written in function notation. So when I see something in function notation and then we're asked to evaluate somewhere like f of 0, that just means whatever is the number on the inside here is going to be our replacement for our x value right here. So right here and at the on the other side of the equal sign. So what we do is we take our equation and we fill in whatever number we're given. So we fill in a 0 instead of x squared plus 5, we have 0 squared plus 5. And then we evaluate that. 0 squared is 0 plus 5 equals 5. So we have just evaluated our function at positive 5. And let's do the same thing for f of 3. Go ahead and pause it and try these on your own. We plug in this number. So we have 3 squared plus 5. 3 squared equals 9 plus 5 equals 14. Same function, different number. This time we have -5 for our x value. So important that you remember to put your parentheses when you're filling in numbers, especially when you're plugging in negative numbers. Because -5 squared equals positive 25, because negative times negative gives us a positive. Plus 5 equals 30. Okay, so now let's move on and see if we can do this with piecewise functions. So piecewise functions are functions they have more than one rule, more than one formula. So the formula for one piece of the function is only applied to certain values of the domain, which the domain again is our x values. So as specified in the definition of the function. So this is an example of a piecewise function, and in our definition we're given two different rules. We have this rule and we have this rule. So both of those rules apply, but in the definition is also including, we only use the top rule if x is less than 0, and we use the bottom rule if x is greater than or equal to 0. So it depends on which x value we're given as to which piece we're going to use, which piece of the function we're going to use. So for example, over here, we are starting with f of -3. So f of -3, we take that over here and we figure out, okay, is that less than 0 or is that greater than or equal to 0? So -3 is less than 0, so we're going to be using this top rule, top part of the function right there. So we plug our -3 into there to get -3 squared minus 3, and then we evaluate just like we did before. So we square it, which gives us positive 9 minus 3, which is 6. And that would be our answer there. Okay, so we're just finding our y values here. If I were to put that on a graph, my point would be -3, 6, because I plugged in the x. 6 is what I got for the y. But here we're just evaluating. All right, f of 4. So again, we go over to this right side of our function. Is 4 less than 0 or is it greater than or equal to 0? This time it is greater than or equal to, so we're going to use this bottom rule. So we plug in a 4. So we get 3 times 4 plus 2, which gives us 12 plus 2, which is 14. So that is our y value on that one. Okay, on this one, f of 0. So this might be the trickiest one because it's kind of our boundary here. So we look over here. Is 0 less than 0 or is it greater than or equal to 0? Since this has the equal to part right there, it is equal to 0, so we are going to use that bottom rule. So we plug in a 0, 3 times 0 plus 2 gives us 0 plus 2, which is 2, as our y value for that point. Okay, so now we're going to use that evaluating process to be able to graph a piecewise function. So we're going to break this into steps. We're going to graph this equation separately and then this equation. And then we're going to put them together and see if we can figure out how to graph this piecewise function over here. So step 1, graphing this equation. Remember this x squared, you remember the shape of this, is a quadratic. And you remember what transformation happens. -1, when I have a -1 at the end, That is a translation or a shift down 1. So if you remember what x squared looks like, awesome. If not, you can graph it on your graphing calculator and find some points from there. Or you can make your own t-chart. XY. So t-chart, but the calculator makes the t-chart for you as well. So let's plug in some numbers. Just plug in these ones. Okay, and then we plug them in and we find our y values. So this gives me a 3, this gives me 0, -1, 0, +3. So it's going to be symmetric. So -2, 3. I plot these all on my graph. And I can put some more points on here. I think this one goes up to 8. That one goes up to 8. So it's always good to put as many points as you can on the graph that you're given. Okay, so there's my first equation. There's my first graph. On step number 2, we're going to graph our linear equation. This is in the form of y = mx plus b. So we start with b, which is our y-intercept. So we start at +1. And then we go for our slope, which is 4 over 1. So up 4 over 1, up 4 over 1. We could go down as well. Down 4 over 1, down 4 over 1. And then we connect that for our linear equation. Okay, so now we have these two graphs. But now to put together our piecewise function, we're going to be taking pieces of each of these graphs and putting it into one function. So we are going to take a piece of this first equation, which I graphed at the beginning, but I only want the piece where x is less than or equal to 0. So we got to look at our x values here. So looking at x values, I only want when x is less than or equal to 0. So this is kind of my boundary right here. So, and I only want this half of the graph, because look at my x values down here. That's where x is less than or equal to 0. So since it is equal to, right on that boundary line, I am going to take that point and have a filled in circle right there. So I'm going to graph that over here. So a filled in circle, and then I'll fill in the rest of the ones that I have from there and put in that piece of the graph. That's the only half that I want, because I'm only allowed to take the stuff when x is less than or equal to 0. Okay, now we look to our second graph, our second piece, which is 4x plus 1. I can only take the piece of this graph that is when x is greater than 0. So that's going to be this half of the graph. So again, 0 is my boundary. This time it's going to be an open circle right on that boundary line, but I'm going to take all of this stuff up here because that's when x is greater than 0. So open circle, copy that over here, open circle on +1, and then my slope, and connect my line. And that is our piecewise function. So we're taking pieces of different functions and creating one function with it. Because this still passes the vertical line test, so it is still a function. Okay, we're going to practice that again. So here we go. We have two different pieces. These are both linear this time, so they're both in the form of mx plus b. So if you want to, you can plug it into your calculator to come up with a table. And sometimes I like doing that and then looking at a table for this first piece right here. I'm only looking at the values when x is less than 2. So when I'm looking at my table, I go to 2 is the highest number that I want. And then I can go less than that. So my x values and my y values. And so for negative x, I'll show you two different ways of doing this, but making a table and looking at the x values, your specific x values that you know that you want, is one way to do it. So looking at those x values, so this will be +1, -1, -2. So I can graph those. This is at my boundary though, and I don't have an equal to sign, so I'm actually going to have an open circle right there. So 2, -2, it's going to be an open circle, 1, -1, which makes sense. My slope is -1 over 1 if you look at it as mx plus b form. And then I just connect that. Okay, so there's the first half of my graph. And then you can also, at the same time, you can plug in this equation into your calculator and then look at the x values that are greater than 2. So when I look at this t-chart, I start at 2. It's still going to be an open circle, but then I look at the ones that are greater than that. So plug it in. So this is going to be a -2, -4, -6, -8 looks like. Okay, so again, open circle right on that boundary line. So 2, -2. Oh, and they connect, but it's still open because it's not an equal to sign right there. So still open. And then we go 3, -4. Yep. And we go down from there using our new slope. Okay, so it looks like a line that's kind of bent and it has a circle in the middle. So there's our first piecewise function. Okay, so another way, instead of using t-charts to do this, we're going to look at another way over here. So looking at this top equation, we can look at this in mx plus b form, mx plus b. So in this case, our y-intercept is 0. So I can start at 0, and then my slope is +1. So I can go +1 in this direction and in this direction. But then if you start like that, you have to go back and look at your x values. I only want that graph when x is less than -1. So looking at your x values, your x boundary is going to be right here, and I only want the stuff that's less than that. So then I would have to go back and erase all this stuff over here. And I would have to create an open circle right there since there's no equal to sign. But then I can connect my dots going that way. For my second piece, I just have y equals 2. So that's going to be a constant. It's going to be a flat line. We have a slope of 0, but that's only between when x equals -1 and +3. So going to -1, I know my y value is going to be 2. And that one does have the equal to, so that's going to be filled in on that side. It's a constant all the way across until we get to +3. That one's an open circle because we don't have an equal to sign on that side. And then we have our third piece, which is, again, it is mx plus b. So if you want to graph mx plus b, we start with our y-intercept, which is +1. Our slope is -2. So -2 over 1, -2 over 1, over and over and over. But then again, we only want it when x is greater than or equal to 3. So here's my boundary right here. So that's going to be the first thing that's going to go in. I'll erase everything, all these pieces on the left side. And then I can connect all of this stuff going this way. Yeah, pretend like that's connected. There we go. That's better. Okay, so you can do it that way as well. So graphing it and then erasing the pieces that you don't need. So there we go. There's our another piecewise function. Our last example. Oh no, we have 2 more. Okay, so this time we're writing the piecewise function. So let's look at this piece over here, and you can connect it with stuff that we've done already. That looks like a flat graph, which is what our constant looked like over here. That was just a number, +2. So this is just going to be a number as well. So looking at the y value is 1 no matter where we are. So this f of x equals 1, that's my first equation. But then I have to say also when that applies. So for what x values does that apply? So let's look over here to see what x values it apply to. So x looks like -2 is our highest one, and then it keeps going this way forever. So it looks like when x is less than or equal to -2, because it is a filled in circle, so that does get an equal to. And now let's look at the second piece. We're done with the first one. Okay, this is linear, so let's think mx plus b. So y equals mx plus b. Let's look at the slope. So slope looks like it's just 1 over 1. So we have 1x, or just x. And then b is our y-intercept, which looks like it's just going to be 0. So we can put a +0 or just leave it. Again, we have to decide what x values this is for. So looks like -2 is our lowest x value, and then it keeps going. This arrow says it keeps going to the right. So this time it's going to be greater than -2 because it is an open circle, so no equal to part in that. And there's our equation. Now we have the last example, which is when we are evaluating just given a graph. Okay, so looking at our graph, the idea is still the same. We're given an x value and we need to find the y value. So let's go to the x value of -1. So on our x-axis, we're going over here and looking at counting every other mark this time. So -1 is right over here. And then we follow it up or down to our function. So follow it up until we get to the function, which is right here. And then we just write down the y value, which looks like it's positive 1. Same thing on the next one. We go to f of 1. So go to x equals 1 on the x-axis. Right here, follow it up to your function. And this is tricky because we have 2 different places that it could be. But if you remember, it's equal to right here. If it's open, the function doesn't actually exist right at that point. It exists next to it, but not right at that point. So we are going to use this bottom one because it's filled in. So, and it looks like that y value is also positive 1. Okay, next is x equal 2. So we go to 2 on the x-axis, follow it up to our function. We're going to skip the open circle because we know it doesn't exist there. And then we go to the filled in circle, which is right here, which has a y value of 3. Okay, go ahead and pause the video and try this one on your own. Our first x value is -4, so you go to -4, follow it up or down. So this time we go down to our function, has a y value of -3. When x equals 0, that's right here on the x-axis, following that up to our function, which is at positive 2 for a y value. X value of positive 3, and we follow it to the function. Remember, this is open circle, so we're going to skip that one. And we go down to where this is. It's a filled in circle. The y value is -2.